Alright, hi everyone. So this will be our third lesson for the topic of trigonometry and it's also the last lesson as well. So for today's learning outcome, we are still under the same outcome, which is how do you use the trigonometry for you to simplify, to solve the equation and to prove the equation and so on. So for today, we are learning how to express the equation of a sine theta plus b cos theta in the form of r sine theta plus or minus alpha or r cos theta plus or minus alpha. Okay, so we only learn one thing today. It might be a little bit tricky at first because it's like a new idea for you, but don't worry, as long as you practice, then you will be able to get the idea. All right, so let's straight away go into our introduction. So yeah, this is the learning outcome or the topic for today's lesson. So for today's section, you are learning how to solve the equation for the form of a sine theta plus or minus b cos theta equals to c. Because the idea is if you have something like this, then when you even you switch this over, right, you cannot have something that's sine theta over cos theta, so you can't change it to tangent, so that's why you can't solve it, so that's why we need to change it in this form, and this form can help us to identify the maximum and the minimum value as well. Okay, so something special about this lesson is I'm putting like a short activity here. So if you think that you are interested to do it, then you can just click on this link. Then after that, follow the instruction. So try to just go through it. Then after that, you only look at the video. I think it is like quite interesting for you to find out. Yeah. So I mean, if we are in a classroom, then we can try to do this together, like in group activities. But since we are doing this like this, so that's why if you want, then you can carry it out individually. If you're not, then you just continue with the video. I'm going to explain and try to do this activity as well. All right. Okay, so I really hope that you have tried yourself. Then after that, you only look at like the discussion part. All right, so let's try to do this one by one. Okay, so the first step, create a graph that y equals to 3 sine x plus 4 cos x. So what do you realize for the graph that you obtain? Okay, so let us try to do that. Okay, 3 sine x plus 4 cos x. So for us to look at the graph easier, then let us try to just set it between 180 to 360 maybe. I think no need so long also, maybe negative 90. Okay, so this is the graph that you can see. So what can you realize here? So actually, if you only look at this part, right, I can see that it's actually something like a sine graph. So meaning if I were to cut at this point and this point, it can be like a normal sine graph also. Okay, but let's say if I try to cut it this part and I further drawing it, what can I realize? I can see that this can be a cos graph also. Yeah, so this is something like very special when we try to add one sine function and one cos function together. Okay, so let us continue for the second step. Create another two graph, y equals to sine x and y equals to cos x. So let's try to do the exactly same thing. Oops, I'm sorry. Okay, so y equals to sine x, no need y, sine x, then after that you put in the range as well. Then after that, the other one will be cos x, and you put in the range as well. Okay, so let's try to put them into different colors so we can look at it like much more clearer. Okay, all right, so these are the two graphs that you get for sine x and cos x. Okay, now let us continue. Okay, so the third thing, by using your knowledge of transformation of function, try to make some changes onto the two functions so that it can produce the exact same graph as y equals to 3 sine x plus 4 cos x. Okay, so in this graph, then we can see that this is sine x and this is cos x. So I think one thing that very obvious for the graph of 3 sine x and 4 cos x is that this graph has an amplitude of 5. So you can see the maximum point and the minimum point is at 5 and negative 5 respectively. So I think one thing that we can do that is very easy for us to start is to change it into 5 sine x and 5 cos x. So this will be like a vertical stretch. Yeah. So which I think this one is pretty easy. Okay, then the next one, maybe what you can try to see is the blue color graph is like here. Then my green color graph is slightly to the left hand side. Then my purple color graph is slightly to my right hand side. So what do I need to do? I might need to do my horizontal displacement. Okay, so let us try to do it one by one. So let's start with the purple color one. So I can see that the maximum point of me here is like 90 and 5. But for this point is 36.7 and 5. So what I will need to do is I will need to move my purple color line to left hand side for an angle for 90 minus 36.87, right? So I can just use my calculator to count it. So I get 53.13. So meaning that I'll need to move to my left hand side. So that's why it should be a plus. So I will try to change this into x plus 53.13. So what you can realize is I get the exact same graph now. Okay, so finish the sine one. Now let's go to cos. Okay, so how can we make this green color line the same with the blue color? So I have 0 and 5, and this one is 36.57 and 5. So I need to move my green color graph to right hand side for 36.87. So to right, that's why I need to minus. So that's why x minus 36.87. And you can see I get the exact same line. All right, yeah, it's pretty interesting, right? So if you are trying out by yourself, yeah. Okay, so let us try to see. So the fourth one, writing down the two function and compare with y equals to 3 sine x and 4 cos x. Do you see any interesting connection with the numbers? Okay, so now let us try to write down the function so we can try to find out is there any interesting facts about that. Okay, let's just write down the three things that we have gotten here. Okay, so this is the three function that we have get just now. So since they produce the same graph, so meaning that these three function actually means the same thing. But the idea is that because we don't really know how to draw a 3 sine x plus 4 cos x graph, so how am I going to know what is the function to change it into sine or cos if I do not draw the graph? So we need to find out what is the connection or the relationship with these two functions and the original function that we have. So let's start with the numbers. So if you can realize, right, 3 and 4, how can you get 5 out from 3 and 4? So I think this one is quite easy. 5 is basically equals to the square root for 3 square plus 4 square. All right. Okay, we are going to try it out later. I mean, this is our assumption, right? Okay, then after that, how about the plus and minus and also the angle here? So maybe we assume that sine will be always plus, then cos will be always minus. But how to decide the angle here? So it's something that very interesting. So you can try out with your calculator. I mean, this is actually very hard to find out. I mean, we are going to prove it in a proper way later. Okay, so you can try shift tangent. So we have the two number here, which is 3 and 4. So when you try to key in 3 over 4, then what you get? You get the exact same number as what you put in the cos just now. So let us write down shift tangent, meaning inverse tangent 3 over 4 give us 36.87. And this is the number that we put in the cos function just now. So same thing. Now let us try to do it upside down. So instead of putting it like 3 over 4, I'm going to put it 4 over 3. So I will get another number that you put inside. So yeah, like 4 over 3, then I'll get 53.13. Okay, now, I mean, without doing our proper proving process, let us try this out and we try to write down the two functions and we check and see whether it's correct or not. Okay, So how do I get my first number? Then it will be a square root for 1 square plus 2 square, right? So I will get square root over 5. Okay, because I can't actually solve it. Yeah, I mean it will give me an irrational number, so we just leave it there. Okay, so the other one, let's try to find the sine one. So tangent, shift tangent, then I will press. So this one is 4 over 3, right? So the number for cos over the sine. So that's why 2 over 1. So I'll try to get this number from my calculator. So shift tangent 2, oops, sorry, shift tangent 2. So I'll get 63.43. So 63.43. Then do the same thing, try to make it uh, upside down, so 1 over 2. So when I press shift tangent 1 over 2, then I will get 26.57. Okay, so now with these two answer here, let's try to write it in the form. So meaning that I will have square root 5 sine, and then since we assume that it's always plus, right? So x plus the first number here, 36.43. Then after that, for this set, the third one will be square root 5 cos sine, cos x minus 26.57. Okay. Okay, so with our assumption just now, so we assume that these three functions will give us the exact same graph. So let us try it out in the graphing calculator. Okay, let us try to key in the three graph plus 2 cos x. Okay, so same thing, we try to put a range. Then after that, square root 5. Do I have a square root? Yeah, square root 5. Okay, then after that, continue sine x plus 63.43. So same range. So I do the same thing for the next one, square root 5 again. And then after that, cos x minus 26.57 and the same range. All right. Okay, so now when you look at this, right, then definitely you can see that all these graph actually have the same places. So you see the first one, second one, the third one. So all these graph, when you show them together, they are actually on the same page. Okay, so this is something that very interesting. So meaning that for every function that you have a sine and cos, you can actually try to change them or try to express it in a way that r sine something or cos something. So now we are going to do the proving part like in a much more proper way. Okay, we'll continue with the proving part. So unlike our previous lesson, the proving part for this section is very important. So please do not try to skip this part. So, and it's not going to be a very long one, and you must make sure that you can understand the process because this formula will not be given in your examination. So that's why you need to understand the whole process so that you don't rely on memorizing formula during your examination. Okay, so you can see our idea here is we are trying to change a function with a sine theta plus b sine theta, plus b cos theta. Okay, like a can be any number, b can be any number, but it must be a same variable for the function, for the angle for the function. And then after that, it can always change into the function of r, meaning a constant. Then after that, sine theta plus an angle. Okay, so what we are doing just now is actually to find the r and the angle over here. So we are going to prove this in a much more proper way. So in your syllabus, right, you only learn the case for all the constant r is positive, and then for your alpha, meaning the angle, the displacement that you are doing, it will be always between 0 and 90 only. So you are not learning anything that difficult than this. So that's why when later when we look at the formula so-called, then you can realize that there might be not included every case when we talk about where you have both negative and so on, because those are the cases that you might need an alpha that is greater than 90. So in your syllabus, we only talk about between 0 and 90, which is an acute angle only. Okay, let us try to do this. So let me just copy first. A sine theta plus B cos theta equal to sine theta plus alpha. Okay, so if you can recall for the compound angle formula that we have learned in the previous lesson, how do you actually expand sine theta plus alpha? So it's actually the formula of sine A plus B, correct? So what do you get? You get sine theta cos alpha and then plus cos theta sine alpha, right? Okay, so let us try to expand this. So r sine theta cos alpha and then plus r cos theta sine alpha. So when you expand it, you can definitely see that this thing must be equals to the one that we expand. Okay, so now we try to do some comparison. So let's try to see, equate the coefficient for sine theta, coefficient of sine theta. So what can you realize? So I have both sides, sine theta here and sine theta here. So meaning that my A should be equal to R cos alpha. You get what I mean? Meaning that when you look at this term, right, I only have the first term with sine theta. So that's why this term must be exactly the same with the first term with sine theta. So if sine theta and sine theta is the same, so meaning that A should be equals to R cos alpha. Then we try to do the same thing for the second one. So I have equating the coefficient of cos theta. Okay, so meaning that now I have cos theta and cos theta. So meaning that my B will be equal to what? My B will be equal to R sine alpha. Okay, so now I have this already. How should I continue? So let's try to do the first thing, which we try to find out what is our angle for alpha first. Since I think this is quite obvious, so I have this is my first equation, this is my second equation. So we want to get tangent, right? So let us try to use the number 2 equation divide by number 1 equation. So what do I have? Then I have B over A will be equals to R sine alpha over R cos alpha. So R and R cancel each other. So what do I left? I left with sine alpha equals to B over A. So how do I get alpha? Because the objective is to find out what is the formula for us to find out alpha, right? So that's why as I continue, then meaning that my alpha will equals to inverse tangent B over A. When you try to look at what we have done just now, is that correct? The example here? Yeah. So when you try to substitute sine, you will use B over A. B is the number that in front of your cos theta, and sine and A is the number before your sine. So that's why you are using 2 over 1, which verify our proving now. Okay, so how about the second part, which is how do we actually solve for the R here? But you see, we have, even we get B and A, but our alpha is a variable also, right? So we must think of a way that you can try to eliminate both. So how can you actually do that? So let us try to do this. So we'll try to square the function for number 1 and 2. So squaring the equation for 1 and 2. So when you square number 1, then you will be getting A squared. So number 1 equation is here. So you will get a square equals to r square cos square alpha, which gives you number 3 function. Okay, so we'll do the same thing for the next one, which is b equals to r sine alpha. So you will get b square equals to r square sine square alpha, which is your number 4 equation. So what do we need to do? So you can see you have cos theta alpha, cos square alpha and sine square alpha, which we have one basic identity that when you add up these two, it will give you 1. So that's why we try to use 3 plus 4. So you will get a square plus b square equals to r square cos square alpha plus r square sine square alpha. Okay, so as you continue, you can always factorize and then you get cos square alpha plus sine square alpha. So cos square alpha plus sine square alpha will give you 1, right? Meaning that r square actually equals to a square plus b square. So as r square equals to b square plus a square, meaning that our r will be equals to square root a square plus b square. Okay, so we are not taking the part for negative because our syllabus only dealing with all the r that is positive. And when you do this kind of question, all the question will tell you that the r is the positive one. So that's why, I mean, even maybe sometimes you forget and you put plus and minus, right? But after that, when you look at your question, you will always have r greater than 0. So that's why you are going to get the one that is positive. Okay, so this one also verify our guess just now, which you have. How do you find? You actually use a and b, you square them, and after that square root to get the r that put in front of your sign. Okay, so this is how we get our first formula, which is if let's say I have a sine theta plus b cos theta, I can always write it in the form that r sine theta plus alpha, and my r is actually equals to a square plus b square. Okay, sorry, I shouldn't use this symbol. Okay, where r equals to a square root a square plus b square, and tangent alpha, or you can write alpha equals to shift tangent also lah, is the same thing. And tangent alpha will be equals to b over a. So this is like the thing that we got. So you can try to use this proving method, then you try out for the other one also, meaning like how do you get the cos one, and how if you have a minus, and how if you have the other minus at the sign part. So you can all try it out. Yeah. All right. But later I'll try to give you a general formula. So that's the thing that you should know. But the same thing during when we try to solve the question later, we'll try to show you the whole process again so that you do not need to memorize the formula for your examination. Okay, so let's try to look at your example. Okay, so this will be the formula, like so-called formula, that you can try to use if you do not want to repeat the process again. So this is a thing that you can try to memorize. So meaning that when you try to change a sine theta plus b cos theta, then it will always be r sine theta plus alpha. So to find your r, it will be always a square plus b square in square root. But then something that you need to note is that when you are dealing with like either cos in front or sine in front, or you want to create a sine graph and a cos graph, your plus and minus sign is going to be a little bit different. So if you want to memorize, then I would say that it's a little bit risky in that sense lah. But if you already confirm that you can remember everything pretty well, then you can go on with that. I mean, I don't mind. All right, but I'm just writing here that just be noted that this formula will be not be given in your exam. So that's why it's very important for you to understand how to do it without referring to this. And then because the process is not very difficult. Okay, so one of the helpful thing when we try to express it in such a way that r sine theta plus alpha is that from this expression, we can actually decide the maximum and the minimum value of the expression. Okay, so we'll try to look at these three examples together. So only three examples because they are just talking about the same thing. So yeah, and then at the end of your paper, I actually put this down because this is like our last lesson for trigonometry already, plus your P1 and P3. So that's why I'm just like putting for you a reference so that you know that these are the set of the formula that will be given in your examination. So it will look like this, like trigonometry section, then they put everything inside here. So anything that is not in this section, which you learn in trigonometry, for example, for this lesson, then is the thing that you might need to be a little bit careful when you prepare for your exam, or try to learn the idea, try to learn the solution. If you I mean, even you don't memorize and you also can solve the problem. Okay, so let's try to look at the three example. Okay, example one, express 2 sine theta minus 3 cos theta in the form of sine theta minus alpha, where you can see the constraint given here. Your r is a positive number, then after that your alpha is acute angle. Okay, so you need to give the alpha in two decimal places and then after that solve the equation. So let's try to solve the first one first. Okay, so I am trying to show this example in the case where you forgot the formula or you didn't want to memorize the formula. But of course, if in the exam you are pretty confident that you can find it by using r equals to square root a square plus b square tangent alpha equals to b over a, then you can I mean go on with that. Yeah, that's totally fine. So something that might be you need to be very careful is like the alpha here, because the sign here is something that might be a little bit tricky for you to remember. Yeah, so that's the idea lah, but don't worry. I mean, if you can memorize the formula and just apply the formula, the marking key will accept it as well. Okay, so I'm trying to show it in the case where you don't remember anything. Okay, so what we try to do is just 2 sine theta minus 3 sine theta, sorry, 3 cos theta equal to sine theta minus alpha. So we try to do the same thing, which is to expand it. So since you already know that your r is going to multiply inside, so that's why to make our working shorter, then you can just try to simplify the step where you can straight away r sine theta cos alpha minus r cos theta sine alpha. All right, then after that you can continue with doing your comparison. So by comparison, you can see that both first term you have the sine theta and sine theta, right? So that's why r cos alpha will give you 2, which is your first equation. Then after that, cos theta and cos theta, meaning sine alpha, will give you 3. So don't need to write negative because you have both minus sign. So that's why second equation. Okay, then after that, you can continue. So your second equation divide by your first equation. So the same thing, you can see this obviously, and then the step of like how do you get to that answer is not how do you get to that answer, is the proving step here is actually not that important, because for the people that can memorize the formula, they can straight away use the formula. So it's fine if you don't actually show everything. So you can actually straight away 2 divide by 1, then you can get tangent alpha equal to 3 over 2. Okay, then straight away alpha give you 56.31. All right, then you get the alpha already. You don't need to get the quadrant 3 because your alpha is only between 0 to 90, which is the first quadrant. So 2 decimal places, which is correct. Okay, then we need to find out our r. So for the r, then you normally what you need to do is to square, right? So you straight away squaring 1 and 2 and add them. Okay, and adding them. Then after that, what do you get? So the same thing, you know that you are going to get 2 square plus 3 square. So since you already know that you get cos square alpha and sine square alpha, right? And this is not a proving question, so you can straight away equals to r square. So meaning that to get your r, you will just do 2 square plus 3 square, which gives you square root 11, 13. Yeah, correct. Okay, so you can straight away write down your answer here, which mean r sine theta minus 3 cos theta will equals to your r, which is square root 13, then sine in your bracket, then it will be theta minus your alpha, which is 56.31. Okay, so just like that. So you do not need to memorize the formula. So you just apply the technique that you have learned just now. Okay, so after you get this, then the question asks you to solve the equation. So this is like the function of like, uh this is the objective of us changing this into sine, because if you have this formula which you have sine and cos equal to a constant, you can't actually change it to tangent, because you do not have something like sine theta equals to cos theta, then you can divide them each other. So in this case, meaning that we need to change this in this form, then only we can solve it. Okay, so B, the question want you to solve 2 sine theta minus 3 sine theta. Let me check again. 2 sine theta minus 3 sine theta equals to square root 2. So equal to square root 2. Okay, so you can see even though you move the plus 3 cos theta here, right, then after that you do not have anything, you can't do anything because you can't divide sine theta. The idea is when you solve for quadratic, we actually cannot divide by x also, because we need to do factorization. So that's the idea where we need to change this. So that's why square root 13 sine theta minus 56.31, which is just substitute what we have got in part A. Okay, then it will be equals to square root 2. Okay, so you solve it like how you solve a trigonometry equation normally. So square root 2 divide by square root 13. Okay, so now you can just use your calculator. Theta minus 56.31 will be equals to, oops, sorry, I forgot to write the reference angle first. Okay, sine, then after that you should be able to get 23.09. Okay, so the questions want the answer from 0 to 360, so that's why you need to find out your angle. Alright, so you are getting 23.09 and sine quadrant 1 and 2. So for this one, you remember actually you need to change, you need to do the range if you can recall. So if we are getting 0 to 0, this is theta, right? So let's say you are finding the x. So the theta here is for your 360. So if you are getting theta minus 56.31, meaning that the range that you should accept is from negative 56.31 up to the number where you have 303.69. I hope that my max is correct. Yeah, you just minus lah. Okay, so after you have get this, so for this question it's still okay because you are dealing with sine. So let's say if this is cos, then meaning that you should take the one from fourth quadrant also, because the range that you should take is from negative 56. But for this one, because you are solving sine, so positive only first quadrant and second quadrant, although you have the range. Okay, so 23.09 and the other one is 118 minus, so you get 156.91. Alright, yeah, let me just write down everything lah. 180 minus 23.09. Okay, so you will have 23.09 and the other one is 156.91. So don't forget you need to solve until the end. So you need to plus them. So 79.4 and 213.2 in 3 significant figure or like 1 decimal places. Okay, so that's the answer for example 1. Okay, so let's move on to example 2. Okay, number two, express 2 cos theta minus sine theta in the form of r cos theta plus alpha, which r is positive and alpha is an acute angle. Then you need to find the maximum and minimum value and the value of theta in the interval which this occur. Okay, so let's try to solve for the first part first before we move on to the second one. So I think I do not want to like do the whole process again, so you should know how do you can actually using the normal process to do it. So I'm just trying to do everything just by using the formula. Okay, so 2 cos theta minus sine theta equal to r cos theta plus alpha. Okay, so you see that a cos theta minus b sine alpha equals to r cos theta plus alpha. So that's why I can straight away r equals to square root a square plus b square, which my a will be 2 square plus b will be 1. Okay, so if you want to use this formula, so please make sure that you remember the correct one, because you see the b and a, if you forgot the sequence and so on, so it might be a problem for you. So that's why I still encourage you to use the method just now. It's just that I think I do not want to like repeat the whole process again over here for the 3 questions. So that's why I should we use this. So you get square root 5. Okay, so the other one will be tangent alpha will be b divided by a. So my b is the one that before sine. So that's why it will be 1 over 2. Okay, so I'll be getting alpha equal to 26.57. Okay, so those are the things that you can straight away do lah. So meaning actually in your exam, they will only give you like mark for this and this. Then after that, the one that you express in the form of r cos theta plus alpha. So later when you try to do your past year question, then you can try to look at the marking key as well. Okay, so from here, then you have finished the first part, which is 2 cos theta minus sine theta gives you r, which is square root 5, then cos theta plus 26.57 degree. Okay, so after you have get this, then let's continue. So you need to find the maximum and the minimum value for this expression. So if you can recall, right, we have learned, so since we know that 2 cos theta minus sine theta is equals to this one already, so let us try to solve from this. Okay, so if you can recall previously, we learned that cos, for anything that cos theta, what is the range? So if you try to draw a normal graph for cos theta, right, then of course you know that it will be in the range of 1 to -1, right? This is what we have when we try to draw a graph. So like the cos graph, so you know that the range will be from like 1 to -1 only, like even though how you continue. Then after that, you can try to see if let's say now your cos is theta plus 26.57, right? So that's why theta plus 26.57. So how is this graph look like? So it's going to be a horizontal displacement where your whole graph is moved to left hand side. So is that going to affect your amplitude? No, your amplitude will be still the same. So that's why it will still be -1 to 1. Okay, but after that, what happened is square root 5, right? So that's why when you multiply the whole graph by square root 5, what happened? So you can imagine when you are drawing this graph, how is this graph is going to look like? It's going to have a stretch, correct? And what's the factor? Square root 5. So that's why when you multiply the whole thing in the middle by square root 5, so meaning that your range will be changed to negative square root 5 to square root 5 as well. Okay, so what is the, then just now we already said that this function and this function is the same, right? So that's why 2 cos theta minus sine theta is also in between negative square root 5 and square root 5. Okay, so the question want our answer to be in like maximum and minimum, then you can try to state it up. All right, so the maximum value will be equal to square root 5, and then after that your minimum will be equal to negative square root 5. Okay, then this is not the end yet. So you need to find out the values of theta in which the interval happens. So meaning that if this function is going to change the amplitude, then the maximum point will happen at what point? So you don't forget, just now we talked about the graph already moved like this number, this amount of degree. So how can we check it out? So the idea is like that. Let's say, can you try to imagine that if I have cos theta in between -1 and 1, right? So how do I know that -1 and 1 happens at where? So you will try to do cos theta equals to -1, then after that you check with your calculator theta equals to what? Or you use the graph, right? Or the other one will be cos theta equals to 1, then you want to get what is your theta. So it's the same thing that we are going to do now. So as we know that the maximum happen when square root 5, so meaning that our cos theta in the middle here should be equals to 1, because when we multiply with 1, then this is how we get square root 5. When we multiply with -1, and this is how we get negative square root 5. Okay, so that's why you will need to continue. So maximum happens, or they use the word occur, is it? So maybe, yeah, occur. Okay, so the maximum occurs when your cos theta plus 26.57 equal to 1. Okay, so the idea is we need to have this is 1. So when it multiplied with square root 5, then this is how you get the maximum value square root 5. So how do you solve it? Then just by using your calculator. So shift shift cos, then this is how you get your value is 360. Okay, then after that you can continue. Theta should be equals to 333.4. All right. Okay, maybe you will have the question that, I mean, for cos 1, right, you know that when you draw the graph, then this is what you get. So actually your first one happened at here, which is where your degree is 0. But you remember just now the whole graph moved to the left hand side. So that's why when we want to find the range, right, then this part is going to be like somewhere here already. It's out of the range that we want. If after that you are going to even minus with 26.57 after you get the answer. So that's why we don't take 0. Okay, so that's why you get your first answer, which is 333.4. So don't worry, later we can try to check with the calculator. So same thing, minimum occurs when the part for cos theta plus 26.57 is equal to -1. Okay, so same thing. So you should know that for cos will be at -1, it should be at the point for 180. Okay, so theta plus 26.57 should give you 180. So what is your theta? Your theta will be equals to 153.4. Okay, so to make your answer better, then you can just repeat everything again. So maximum value equal to square root 5 when theta equal to 333.4. And the other one is minimum value will be equal to negative square root 5 when your theta is equal to 153.4. Okay, if let's say you want to check it, how can you do that? So you just press in your calculator and see whether when you substitute this value, do you get square root 5. So for example, the 333.4, right? So let's say it's this one. So square root 5, square root 5 when you multiply by cos 333.4 and then plus 26.57. Okay, so you should get a number. So you can see from this number, you get 2.236, right? So don't worry, you try to press again square root 5, what's the value? So 2.236, yeah, so this is correct. Then you can try to do the exact same thing again. So square root 5, and then after that, multiply with your cos theta. The second value that you get is 153.4, and then plus 26.57. Okay, so you see you should get negative, so which is negative square root 5 that you have. So this is to prove that your answer is correct. Okay, so the idea is you can just remember you want to find the I think for the maximum part, this you should have no problem. It's basically your R value, the positive and the negative will be your maximum and minimum. Then after that, where it occurs, it will always be what do you have for the cost part. Then one make it 1 and the other one make it negative 1. It's the same thing for sine also, because the range for sine is 1 to negative 1 also. Alright, okay, so let's look at the last questions. Okay, number 3, the last one. Given the function f theta equals to 1 over 3 plus sine theta minus 2 cos theta, find the minimum value and the maximum value. So I'm putting in this question because I think that it's actually quite challenging and it's quite special compared to the first two questions. Like they didn't give you an exact form that which are you going to change it in a sine graph or a cos graph, and the expression that they give to you that need you to change is different as well. Okay, so when you look at this function, then you will know that actually you can't change everything in one shot. So meaning what do we need to do is we can only look at this part first. So sine theta minus 2 cos theta, and you see this question didn't give you like whether you need to change it to sine or cos. So the idea is like this: when you look at the difference between these two formula, right? The idea is as long as you have your sine positive and you have your cos as negative, then you will always use sine. I mean, in the case where you have both positive or both negative, sorry, we don't learn for the part for both negative. So when you have both sine and cos positive, then no matter you change it to sine or cos, is totally fine. But it's just that if your cos is negative and only sine is positive, then you must change it into sine. If your cos is positive and your sine is negative, then you must change it into cos. Because if you do it like in another way, then you will get an alpha that is not an acute angle. Yeah, you can try it out with the Desmos graphing calculator if you want to. But the idea is just that if you have only sine positive, then you use sine. If you have only cos positive, then you use cos. So if you have both positive, then either one you will get the exact same answer. That's totally fine. Okay, if the question didn't ask you to change to one specific one. Okay, so meaning now you can see your cos is negative, so your sine is positive. So that's why we try to use r sine theta. So since this is minus, so that's why minus alpha. Okay, so we can continue now. So how can we do that? So the first thing we can, we just try to use the formula over here lah. So to make the process shorter, okay, a square plus b square. So a is 1 and b is 2. So you get the same thing, which is square root 5 as well. Then after that, let's try to solve for alpha. So tangent alpha equals to b over a. So in this case, your b is 2 and your a is 1. So you are getting alpha will be equals to 63.4. Okay, so let's try to write it. So you get sine theta minus 2 cos theta actually equals to square root 5 sine theta minus 63.4. Okay, so after you have all this value, then now you should be continuing with the maximum and the minimum value. So how can we do that? So don't forget your function is not this one, your function is this now. So your f theta is equal to 1 over 3 plus sine theta minus 2 cos theta. And the maximum and minimum you want to find is based on this function. So, but let us continue. Let us start with what we usually do. So it's the same thing. If you are not familiar yet, then you can start with sine theta will be in between 1 and -1. Then after that, when you have sine theta minus 63.4, you are still getting 1 and -1. Then when you times with square root 5, then you will get square root 5 and negative square root 5. Okay, so if you are very familiar with this already, then what you can try to do is this two step you can actually skip and straight away go to this, because you can actually take all your thought process in your mind. Okay, so after that you can continue. You can see what happened here is this is the one that represented this, right? So you can try to change it. So sine theta minus 2 cos theta will be the same, square root 5 and negative square root 5. And then after that, they do 3 plus, so you need to do the same thing as well. So 3 plus theta minus 2 cos theta. So since you are plus 3, right? So that's why it will be 3 minus square root 5 and 3 plus square root 5. And don't forget you have your last step, which is 1 over. So 1 over 3 plus sine theta minus 2 cos theta. Okay, so this is the thing that you must be very mindful here. So you are doing reciprocal. So you might need to check out like whether this value is smaller or this value is smaller. Because let's say if you have 2 and 5, after I put in 1 over 1 over, it become different thing. So 5 is greater than 2, but 1 over 2 is greater than 1 over 5. So that's why you must check like which is a smaller. So 3 minus square root 5, so just now square root 5 is like roughly 2.23, so you are getting like 0 point something. And here, you are getting like 5 point something. So when you do 1 over, this is going to be your minimum. So that's why don't forget you should change your arrow. Okay? Because when you try to find the reciprocal of it, then definitely the bigger than and smaller than will be changed. So this is what you get. So meaning that your max will be equals to 1 over 3 minus square root 5, and your minimum will be 1 over 3 plus square root 5. So the same thing, you need to find out where is the where does the angles exist for this maximum and the minimum point. So let's try to do the same thing again. So what is the value just now? So sine, so max occurs when your sine theta minus 63.4 will be equals to -1 or 1. So you see, this is the part that makes the changes, right? So the negative square root 5 give you the maximum. So that's why max occur when your sine is actually equals to -1. Because only you need -1, then it become negative square root 5. Then after you continue, then this become your maximum. So that's why this part must be equals to -1 for you to get the maximum. So you solve with your calculator. So theta minus 33.6. So for sine -1, so same, you can use your graph to do that. Okay, so -1 is here, so it will be 270. Okay, so you can continue to solve that, then theta will equals to 333.4. Okay. Yeah, sorry. So it should be 333.4. Yeah, I only realize it when I do my editing. So try to change it in your answer. So same thing, you can find it for minimum. So minimum occurs when your sine theta minus 63.4 will be equals to 1, correct? Because you need 1, then only you can continue so that you get the minimum just now. So when it equals to 1, then it will be like at the top there, so the minimum graph. So that's why theta minus 63.4 should give you 90. Okay, So theta equals to 153.4. Alright, so now you can write down your last answer. Okay, so maximum value equal to 1 over 3 minus square root 5 when theta equal to 33.4. Okay, sorry, so this should be 333.4 as well. So the other one, minimum value equal to 1 over 3 plus square root 5 when theta equals to 153.4. So the same thing, you can try to use your calculator, just substitute these two values inside here to check that whether you get square root 5 or not. Okay, so that's the idea. All right, so that's the part for today's lesson. So let's do a very quick recap for this chapter, since this is the last lesson that we have for trigonometry. Okay, so let's do a short one because this topic is actually quite a short one also, which we completed everything in like a week. Okay, so the first thing that we learned when we first started the lesson is for the function for second, then cosecant, and also your cotangent, right? So for this part, we learned that like secant x is actually 1 over cos x. Then you have you have cosec x equals to 1 over sine x. Then after that, you also have the last one, which is cotangent x, will give you 1 over tangent x. Then under this part, you also learn what is the graph. Okay, then after that, when we talk about the second learning outcome, it will be pretty much on the formula part. So how to apply the formula. So under this part, there are few things that you must make sure that you know how to do. So basically, you are using your formula to help you to solve the problem and also to prove the problem. So I just want to clarify again, right? In your exercise, there's a part for inequality for the trigonometry. So actually this is not in your syllabus. You can just skip it. Yeah, that's just like extra exercise that they try to put in the textbook, but it's not necessary. You can just skip for that part. So the formula we have learned is like the basic identities, which we learned about the second square theta equals to 1 plus tangent square theta, and the other one is the cosecant square theta equals to 1 plus cotangent square theta. Okay, with the basic identities, the cos square theta plus sine square theta give you 1, that one. Okay, then after that, the second one you learn about the expansion for the sine a plus b or a minus b. Then after that, you have cos a plus or minus b also. Then the last one, the same thing, you have the tangent one, which what we call as the compound angle formula. Then after that, the next one, you learn about the double angle formula. So double angle, okay, which we talk about your sine 2a, then cos 2a, and also your tangent 2a. Then after that, the last one, which mean for today's lesson, you learn actually how to express the function of expression maybe. So it's like, how do you actually express a sine theta plus b cos theta in the form of like, sorry, I don't have enough space, sine theta plus or minus alpha, or the other one is like cos theta plus or minus alpha. Okay, so those are the things that you have learned under the topic of trigonometry. So you can take this like as a guideline, so you know that next time when you do revision, then you know that which one you know, which one you didn't know yet. Okay, so that's it for today's lesson. So spend your time to finish your exercise and so on. Thank you.